Okay. So I would posit to you that those videos show that we're in a bad place. So if we say we're trying to deal with murder, right? Of course, there's different ways to deal with that thing, but we all, I believe, would be in agreement, or 99.99999% of us would be in agreement that murder is a bad thing, right? If I said we need to deal with murder, I doubt that would break people into laughter, right? I doubt that would break people into like murder. What a dork, right? Because we all take that seriously. We all agree that that's a shared value, that we in an ideal world, people wouldn't be murdering one another. Unfortunately, we seem to have lost that conversation that we're all in this together in terms of several things, and climate change is but one of them. So let's talk a little bit about what's going on now, with what the facts are, and kind of where we're going. So this is, so I don't like to talk about global warming, I like to talk about global weirding, because that's really what this climate changed world is going to be. Some places are going to be warmer, some places are going to be colder, some places are going to be drier, some places are going to be wetter. So some of the rhetoric around this has very ignorantly, very disingenuously hooked in on one thing: warm, cold, high, low, whatever. And the notion is, oh, well, it's not like that all the time. So really, global weirding is a lot better term, I think. And so let's talk about what we know right now. These are we'll talk about specifics in a second, but these are just a couple highlights from the report that came out right after Thanksgiving, because the best time to release a national assessment that talks about threats to our country and world and stuff is right when people are out shopping and not paying attention. That's the best possible time. So good on you. As we mentioned before, so we have these national climate assessments that come out every 4 years. We have the Intergovernmental Panel on Climate Change, which is an international entity, and that is the gold standard for what we currently understand about our changing climate and about our impacts on there and knock-on effects and all that kind of stuff. Virtually everybody uses the IPCC data, and they do other stuff with it. So for example, in this case, the National Climate Assessment, which happens every 4 years and is a legal requirement of the federal agencies and the US government, have to get together, pull together stuff. The National Climate Assessment is required by law to pull together science, the best science, not only from our federal scientists, but also pull together academia and other research that's pertinent, pull together, synthesize it, and summarize stuff so that for the public, but also for policymakers, they can turn to this document and they understand what the ramifications are for our particular country. And again, the most recent one just came out. So here's a couple things. So and again, I'll just reiterate, this is a product of the Trump administration. This is a product of our federal government. And so as we just heard, the president said he doesn't believe the results, but they're true. So anyway, so a couple of things just pulled out here. Firefighting costs will go up to at least increase to at least $13 billion needing to be spent in the coming years. We're going to have at least 3 times in the coming decades, at least 3 times as many large fires, defined as something over 5,000 hectares, so big things. So we're going to be having lots more big fires, and they're going to be a lot more costly. So what we saw with Thomas Fire last year, we saw the Camp Fire this year, we saw with the fires in northern, Napa and in Sonoma, that area, what we saw with the Woolsey Fire. This is becoming the norm for us, particularly in our part of the world. All kinds of things. For example, you guys are going to have way more allergies. You're going to be spending billions of dollars more on allergy medicine. Many more people that have allergies will have more intense allergies. Many people that have not yet developed allergies will develop allergies. So I did my undergrad at UCSB, and UCSB, like here, right, we have these mountains, but UCSB even has these longer transverse mountains. So we get the Santa Anas, they get some Santa Anas too, but they also pull a lot of air from more of the Central Valley and Santa Barbara just because of where they're located. So typically takes 4 years to go through undergrad, right? So fully 1/3 of the people, undergrads, that would go to UCSB for undergraduate education that came without an allergy, seasonal allergy, by the time they graduate in 4 years, have developed seasonal allergies because of just being exposed to all this pollen and ragweed and all this and that. So that seems like that's not as consequential thing as losing your house, but those of you that have seasonal allergies know that can make life really miserable, right? Runny nose, headaches, and missed work, and all that kind of stuff. So what the climate assessment is telling us is that there are both these big, sexy, obvious things, but there's also this more chronic, day in, day out impact that we sometimes ignore. So doing these periodic assessments allows us a chance to step back and talk about some of these impacts and to think about them more fully. A huge amount of property is underwater in the US. So somewhere between, and again, it depends on the assumption of the models and how fast things are going to go, but somewhere between $66 and $106 billion of property, that's public and private, right now, that are in existence right now, will be underwater, and that's primarily at the coast, although it does include some areas around the Great Lakes and places like that, but primarily around the coast by 2050. We started off our semester this semester with the onset of Hurricane Florence. We spent some time talking about that. Some of the, well, I haven't seen the peer-reviewed stuff, but some initial estimates came out suggesting that sea level rise, not hurricane caused, but just due to sea level rise, the impact of that hurricane was greater than it otherwise would have been. So in other words, folks are more vulnerable than they would have been without that sea level rise. And sea level rise alone damaged probably at least 11,000 additional homes in the Carolinas in that area. The insured losses from that is on the order of somewhere between a little bit less than 3, upwards of $5 billion. That's insured losses. There's also uninsured losses, which are greater and harder to tally up. Another key finding from the climate assessment is transportation is going to become increasingly difficult. Obviously, there's the things we think about, such as hurricanes and typhoons messing with international shipping and causing problems, of course. But increasingly stuff that we haven't really thought about, such as road damage. So we'll need to be spending at least $20 billion extra dollars than what we need to be spending right now, just additional damages to our freeways, roads, etc., because of primarily storm-induced and flooding-induced impacts. And that's by 2050. That's by 2090. They also called out somewhere between 2,500 and a little bit less than 5,000 bridges are at risk. Those bridges alone will take between $1.2 and $1.4 billion to repair, either emergency repair or that need revetments before they fall down by 2050. More mega droughts, and a mega drought is defined as a drought that lasts at least 10 years. We'll be seeing more of those. We're going to see declines in tropical fisheries. So we're going to see impacts here in our fisheries in California. And then something that the report doesn't call out, but I just put in there as a bullet from my interpretation. But as you guys noted in one of our questions of our quiz there, this is going to push more to degrade environmental justice, right? This is going to be the poor will bear the brunt of this, whether that's folks living in paradise or whatever, as our discussion just went about Malibu versus paradise, right? And as a knock-on effect, we'll see, and we're already starting to see this, right? Increasing tribalization, we're going to save America and let these other countries go, or we're going to save this region of America and let this other region go. That seems to be, this is done. This is all going to happen. The question is, do we want to try to mitigate this and not have this be as bad as it otherwise could have been? But we're now into the realm of this is going to happen. It's no longer can we prevent this, it's can we make this not as horrible. So this is the slide from last year's lecture, this my final lecture last fall. And so this is the data from on top of one of our longest term data sets on top of this volcano in Hawaii, right? And so back then, a year ago, we were at 406 not quite 407 parts per million in terms of atmospheric CO2. This is the data. The most recent updated verified data is from December 3rd, a couple days ago. And this is 409. So we're going up. Merry Christmas. Ho, ho, ho. So what have we known for a long time? We've known for a long time that global temperatures are going up. And there is no, and that's the reality. All this silliness that people will attempt to tell you to drink this poison and to believe this lie, that this is the reality. The temperature is going up. And more importantly, we've known it's been going up since the late 1800s. So this is not some conspiracy of scientists in the 1980s or people that want grant money in the 1990s or anything like that. This is a well understood phenomenon. We're not exactly sure of some of the specifics in terms of how intensely the slope is going to be up or down, but the slope, we absolutely know that there's a slope and that we're heading in this direction. In the report, and there's a lot of stuff coming out in the last couple of years about particularly polar regions. We hear a lot about Antarctica, hear a lot about the North Pole, but particularly since this is a national climate assessment, there's a lot in there about Alaska, because that is our most polar area, with the exception of our research bases in Antarctica. And the poles are changing faster. The polar regions are changing faster than our more temperate and tropical areas. So they're seeing some of the greatest shifts in things. What we've learned more recently is how the extremes are changing. The models that we use for the IPCC report, so IPCC reports, just like the National Climate Assessment, they're not every year, they're every so often, they're sort of phased in. And so it takes a few years to get the next update. The IPCC is a consensus document. A consensus document means that that everybody agrees on this. All the parties agree, right? So for a lot of the models that we're using, so the IPCC generates these things. We run all these different scenarios, and there's high, medium, low, and there's this scenario, that scenario, whatever. And then Gesundheit, we tend to take the middle ground often, right? So okay, well that seems kind of crazy. So what's happened historically is we've run these models, and say our friends down in UC San Diego run the stuff down at the supercomputing center, or our friends in Japan or wherever, they run these models, and some people go, oh my God, sea level rise is going to increase by 3 meters. And actually partly informed by the political debate around climate change, but also just because we don't know, and we're figuring out the best way to model this stuff, and we're getting better every year, but we don't know. People look at those and they go, oh my God, 3 meters, 4 meters rise in sea level? That's crazy. People won't believe that. Are you sure about that? I don't know. These other 5 models only show 1 meter rise in sea level, or half a meter, or something like that, right? So what has essentially happened is, in the early models for the IPCC, we say, oh, we don't want to use the crazy scary numbers. We're going to use something less. And pretty much what everything is shown is that those modeling estimates are an underestimate of the rate of change. So the magnitude is greater, the rate at which we're getting to a certain level is happening more quickly. And so we were overly conservative in our models. So those models were the models that, say, were approved by the George W. Bush administration, that were approved by Putin, that were approved by India. These folks that historically have been averse to climate science. And so we're seeing the legacy of that. Now people are getting more and more surprised every year. Another one that we've learned much more recently is that atmospheric rivers are becoming more the norm. This is these massive, this is for particularly for our region of the world, massive deluges. So when it dumps a lot over a short period of time, and it's called an atmospheric river because it seems like it when you're in one of these events, it's kind of clear and it's whatever, and it starts to rain, and it is almost like you're under a waterfall, right? So something more akin to what you might see in the tropics or in a monsoon condition, but we're seeing those things more commonly in places like Southern California and the Sierras and stuff. And when we have these wildfires layered on our system, these massive deluges are a recipe for huge soil loss and erosion and damage. Melvin, do you have a question? Okay, cool. Other things? Yeah.
Kind of is bugging me. You said that Bush Senior put in the climate climate change assessment?
Pass a law that required that every 4 years we do a national climate assessment, correct?
How come there's only been 4 if he was president like 23 years ago?
Because it didn't start until whatever it was, 97 or something. And there were some delays in starting it up.
Okay.
Yeah. Yeah.
Shit, I didn't
Yeah. And the planning for this starts earlier. So some of the initial results in this came out last year, for example. Okay, where was I? Yeah, so we're beginning to understand there's different impacts would depend on where we are latitudinally. One thing we're seeing that hurricanes are dumping, when the hurricanes do come, they're actually dumping a lot more water. We saw this last year with Houston, right? The record rainfall in the U.S. happened during when Harvey was parked over the metropolitan area of Houston and just dumped meters of rain. Okay, right. And then what are we just starting to understand? We're getting more real with these sea level rise estimates. So people are now seriously starting to talk about 3-meter rise in sea level by 2100. So just to be clear, not you, we're up in Sierra Hall, up in this high building and this part of campus, but the other parts of campus, the edge of campus, we're about 5-6 meters above sea level, right? So 3 meters, or okay, gets higher than that, campus might not be in existence for in decades to come. So these are real issues. And again, because we've had this childish, ridiculous fight over what reality is, we've twiddled our thumbs, and so now the momentum that's baked into our inertial climate system is such that we can't stop it, right? We can definitely take actions, we can definitely make things better, but there is so much momentum, a lot of these impacts are now baked in. So it was a choice that our society has opted for, and for the folks that told you things like it's too expensive to deal with climate change, they completely lied right to your face. And what they really said is they want you to spend trillions and trillions and trillions of dollars more, because we're going to be dealing with it after the fact, as opposed to, as with everything, with all of our management challenges, it's way better to deal with stuff earlier rather than later. And it's very clear that we've had no analog for our current climate that we're experiencing now in at least tens of millions and probably over 100 million years on the planet. So we have had these conditions before, but not when our species was cruising around, not when we had agriculture, not when we have had our civilizations as we have had. So let's watch a little quick video just to make the point. Okay, so here we go. So we're starting in 1979, and this is the reference level down here. And this is, and then we're going from the North Pole to the South Pole. So this is different atmospheric CO2 levels. And on the right here, I'm showing you the graph of what that looks like. So obviously there's seasonal up, seasonal down. There's always a little bit of noise in the system. But the long-term trajectory, in this case shown on the right-hand side by the blue line, the trajectory is up and up and up and up. Okay, so we're going higher and higher. And on the right is parts, and on the left is parts per million, atmospheric CO2. Getting higher and higher. Now we're in the late 90s, getting higher and higher. Seasonal stuff, wildfires, other things, seasonal production of factories and things. I'll show you a map in a second after this. Okay, so now we're going to start shifting to provide the proper context. So this is just since 79, right? So we're going to freeze in a second, and the graph on the right is going to expand, and we're going to look at the last 800,000 years for reference. Okay, so now so here we go. So now we're going to start going back in time.
Is this video on YouTube? Or is it something you made?
It is on YouTube. Why did it stop there? It is on YouTube, but this is, I didn't make this. No, this is from some climate researchers. But you guys can find it on YouTube if you want. So Here we go. And so we're using different data sources, so which is why the colors are changing, different ice cores and different sources of estimating atmospheric CO2. And so this is, K is 1,000 years before Common Era. This is what that abbreviation is for. Again, noise in the system, noise in this historic data, but the big picture does not change, regardless of the metric or anything. So when we had our ice ages running the show, we were less than 200 parts per million, and then we're done. Okay, sorry. So you guys get the idea. Oops. So here is a YouTube video. So let's look a little bit more specifically at the spatial distribution of this stuff. And so this is a YouTube video, this one, and this is just for 2006, and it was produced a couple years ago. It takes a long time to run some of these simulations. So this is real data, but then put in a model. So the data points were discrete data points, but this is integrated in a larger atmospheric model.
Hi, this is Bill Putman. I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere. The visualization compresses 1 year of data into a few minutes. Carbon dioxide is the most important greenhouse gas affected by human activity. About half of the carbon dioxide emitted from fossil fuel combustion remains in the atmosphere, while the other half is absorbed by natural land and ocean reservoirs. In the Northern Hemisphere, we see the highest concentrations are focused around major emission sources over North America, Europe, and Asia. Notice how the gas doesn't stay in one place. The dispersion of carbon dioxide is controlled by the large-scale weather patterns within the global circulation. During spring and summer in the Northern Hemisphere, plants absorb a substantial amount of carbon dioxide through photosynthesis, thus removing some of the gas from the atmosphere. We see this change in the model as the red and purple colors start to fade. Meanwhile, in the Southern Hemisphere, we see the release of another pollutant, carbon monoxide. This is a gas that's both harmful to the environment and to humans. During the summer months, plumes of carbon monoxide stream from fires in Africa, South America, and Australia, contributing to high concentrations in the atmosphere. Notice how these emissions are also transported by winds to other parts of the world. As summer transitions to fall and plant photosynthesis decreases, carbon dioxide begins to accumulate in the atmosphere. Although this change is expected, we're seeing higher concentrations of carbon dioxide accumulate in the atmosphere each year. This is contributing to the long-term trend of rising global temperatures. The Orbiting Carbon Observatory 2, or OCO2, will be the first NASA satellite mission to provide a global view of carbon dioxide. OCO2 observations and atmospheric models like GEOS 5 will work closely together to better understand both human emissions and natural fluxes of carbon dioxide. This will help guide climate models toward more reliable predictions of future conditions across the globe.
Okay, so that's a little bit of the dynamic nature, right? So you guys are asking like, where is it coming from, et cetera. We all share this atmosphere, and there's all kinds of drivers. There's all kinds of anthropogenic sources, both the direct emissions, indirect things by promoting burning and other activities like that. So we do. Long story short is human drivers are what's doing this. We know this, and there are some things that change, like the eruption of volcanoes and stuff that have some influence on sulfurous compounds that scatter light and things. But this is a human-driven phenomenon. Again, this data is from these graphs are from, I'm showing you here, are from the report that was just released the other Friday. And most of these reports use various scenarios, so that's very common. So you'll see a high, medium, low, or a high, high, and a low, low, and all these different ranges. And so a lot of times when you get a output, hey, what will this situation look like when we model it in 20 years, 30 years, 40 years? Usually you'll get a range of answers, right? And so hopefully we go down the path of having the least impactful of those ranges, but it's also informative to look and see what's going on. And so, for example, in this case, when we're looking at a rainfall, if we pick somewhere like, let's say, the southern part of Texas, or well, forget that. Let's just say take Southern California here. It really might matter which scenario we're using, etc. But you can also get some consistent patterns that are changed all the time. As far as what will be happening with our coastal environment, you guys probably know most of this, but here are the predictions from that recent report. Higher water temperatures and what we now call marine heat waves. This term didn't exist when I was going to school. We're now recognizing, just like we have heat waves on land, we can have the same phenomenon in the ocean. And so extended periods of elevated temperature. And so we're seeing those. We'd never seen those before, or essentially never saw this before. More acidic oceans, more and more species being vulnerable, particularly marine species. More storm surge. Obviously the sea level rise, we've already mentioned. Persistent or at least recurrent coastal flooding in the same areas over and over again. So again, those folks in Dana Point that said, no, we don't want to do manage retreat, they sure will want to when it becomes every other year their house is getting flooded or their house is threatened with crumbling down the cliffside. More coastal erosion, more critical infrastructure, and decreased water quality, and also decreased water availability. Again, for us in the U.S., that's going to suck. But for many parts of the world, that might mean people just die. So here's an example from a recent paper this year on marine heat waves. And this is showing that we're starting to see these. This is a global phenomenon. So we have here in California, we're one of the places where we're seeing these extremely elevated, extremely warmer temperatures of the ocean. And I was on a conference call with some of these guys a few weeks ago. And so this is surface water, and I asked them about modeling the water at depth, and obviously everybody agrees, yes, it's going out at depth as well, but we don't fully understand that. So these models are primarily shallow surface water, so talking like 30 meters, 50, 30 meters in shallower type of thing. But what you see is, the important part is that it's not limited to one area, it's going on, and it's popping up here and there, and these are becoming more problematic. And so the folks that are working on this are trying to create more like we create a weather forecast. Oh my God, you guys get ready. It's going to be crazy hot the next few weeks. Trying to do the same thing for ocean weather to forecast. Oh my gosh, this is going to be exceedingly warm for X period of time. Then we get onto the topic of ocean acidification. So there's all kinds of knock-on effects of ocean acidification. We can watch a little quick video here on this one.
By now you've heard that the way we're living is filling up our atmosphere with carbon dioxide. As a result, the planet's warming. Heat waves and floods are more likely to be extreme, and people's lives will get tougher. And the more we learn about climate change, the more risks we uncover. Since we started burning fossil fuels, the ocean has absorbed about half of all the CO2 we humans have put out. That's why it's called the planet's biggest carbon sink. Now this is good because it's kept a lot of CO2 out of the atmosphere. But as the ocean warms, it takes up less and less CO2. And with all that CO2 in the sea, scientists are shedding light on, well, an ocean of problems. Ready for the first big problem? Some sea creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. Okay, You've got bigger problems than easy to crack clams? Maybe not if you're among the 1 in 7 people who get most of their protein from seafood. Or if you understand how unstable the world would be with 1 billion more hungry people. What's weakening the shells? Well, these little creatures are going about their lives scooping up molecules called carbonate ions to be the building blocks of their shells. But when CO2 reacts with seawater, it releases hydrogen ions, which compete with shells for carbonate. With more hydrogen ions floating around in the ocean, our little friends have to spend more energy building their shells and have less energy for finding food. That means it's harder to grow, and more will die off before they get big. So the fish that eat the clams or live among the coral will have a harder time surviving, meaning the fish that dine on them won't have enough to eat, and so we won't have enough to eat. Remember those pesky hydrogen ions generated by more CO2? They don't just take away the carbonate ions that these little clams need. They also make the ocean more acidic. It's already become 30% more acidic since we started spewing all this CO2, and it could get much worse. We could change the ocean's chemistry so much that shells actually start to dissolve. That means if we don't turn this problem around, your great-grandkids might think of reefs the way you think of a dodo bird. And with 1 in 4 ocean species living in coral reef ecosystems, weaker coral could threaten the foundation of the whole ocean food chain. But why panic, right? Life always seems to find a way to adapt, but it needs time. In a few decades, we might make the oceans more acidic than they've been in 20 million years. It's hard to imagine any ecosystem quickly adapting to that big of a change. But things don't have to get that bad. We've started this problem, and we're going to fix it, beginning at its source. Carbon dioxide from burning fossil fuels.
So all kinds of knock-on effects from this more acidic ocean. And as we look at this more and more, we find more effects. So obviously there's the most obvious one are critters that have conspicuous calcium carbonate shells. Those folks are unable to lay down their shells. And so we're seeing this firstly in the Pacific Northwest, where we get a lot of our oysters and shellfish and clams and things, at least here on the West Coast. It's sometimes some time of the year in some sites babies can no longer metamorphose. Larvae, molluscan larvae can no longer come out of the plankton and start forming a shell. There's just not the chemistry doesn't allow that. So what we have to do is we have to start in a laboratory condition the babies forming their shells and then manually put them out. So we talked about with our fisheries that the future of a lot of our fisheries is human augmented, right? Even though it's wild caught, that we would do something. We talked about the hatcheries in Alaska and things like that for salmon. Same kind of idea. And so that is becoming a problem, makes it a lot more expensive to do oyster farming. And then we're seeing all these other effects that are behavioral and ecological effects as knock-on consequences of this. So we watched a video last week about what would a world be without plastic, right? What would a world be without shellfish, right? That might be a more useful video. Okay, so here's some data from a paper a couple years ago. So this is reconstructing historic, this is off our California coast here, right? Southern California coast. Historic surface water acidity pH. And then current, this paper was published in 2006, I think, or at least used data in 2006. And then estimated in 2050, and this is depth profile. So what does it mean? It means that our waters are getting more and more acidic here. It's not just a problem in certain areas, or not just a problem for coral reefs or for the Pacific Northwest, but it's a globalized phenomenon, and it's impacting us right here in Southern California. One of the areas that's now beginning to get attention, that was a fair amount was devoted to it in the report the other week, was the impact on fisheries, and particularly the impact on our West Coast fisheries. So we mentioned that tropical fisheries are going to start to have problems, and essentially the critters are moving away because it's getting too warm, is what the prediction is, and so they'll move north and south. And so while our fishes go away, other things should, in theory, come in. We've seen that with Humboldt squid, giant squid. Has definitely moved into California as a result of climate change. Used to be off of Mexico, and we'd only see them occasionally in an El Nino year. Now those organisms are there's a resident population in Monterey Bay now, for example. Okay, so what we see is so some, again, with everything, not everybody is impacted the same way. Some critters will become more abundant, like urchins. Other things will become less abundant. Other things will be really, really heavily whacked, such as some of our flatfish and flounders and things. We're also seeing impacts on surface water, oxygen, etc. We already mentioned the atmospheric rivers. Here's an example from 2006 that really nicely illustrates this, where we see this is essentially deformation of this tropical atmospheric moisture is essentially pushed up, and that's where we get these dumping on rains around Christmas time, January, February, just dumps. And again, more cyclones. We talked about this in the context of hurricanes earlier, but we are seeing more intense tropical storms. One of the big worries is our tipping points. And so this is the term for things that the system just doesn't get a little bit worse, and then a little bit worse, and then a little bit worse, and then a little bit worse. We can actually start to see state shifts and to go from one thing to another. So for example, from a macrocystis or giant kelp-dominated reef to a denuded reef, to go from a bluff system that's mostly comprised of native vegetation, et cetera, holding the soil in, to a naked bluff where the soil just erodes every year, that kind of thing. And so there's more and more work going on to so-called potential tipping points. Long story short, we're getting closer. And these areas highlighted here in the illustration on the left are places where we think some of those tipping points might begin or could lead to major long-term changes. As I said before, we have all these scenarios. So in this case, we're looking at sea level rise, predicted sea level rise. Again, sea level rise is not uniform across the planet. The elevation of the ocean is not the same here as it is in the upper part of Baja, as it is in fjords up in Norway, etc., for a variety of reasons. But this is looking at the overall average, essentially, for the planet. And what we're looking at here is, so this is change, and because this is created by the U.S. government, they use feet. Merry Christmas, right? Because they can't possibly use scientific units. But anyway, so here we go. So feet, and so the long-term average is the 0 at the and so what we see here is with these different scenarios. And so these different RCP2, these are different assumptions of how much we are able to mitigate CO2 going in the atmosphere through different reductions in decarbonizing the energy stream or different mitigation measures or what have you. And so these are run in different run through different scenarios. And what we see is we can have significant difference. So we are absolutely going to see sea level rise, right? But again, we said the magnitude is not, we're not sure about the magnitude, but certainly the spread is the important part. So we're talking orders of magnitude different values in terms of if we just do the so-called business as usual scenario or if we do different reductions. And then, of course, one of the things that this report highlighted was the cost, because that seems to have gotten people's attention. And so what we're modeling here is with all this stuff, with all these things and the sea level and the flooding and the blah, 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 let's just start doing some, quick and dirty back of the envelope tallying. And so we're pretty clearly into, the trillions of dollars at a minimum in terms of direct costs from these impacts. So that's trillions of dollars we can't spend on you guys or your kids or environmental protection or whatever. Okay, finish up. I just want to talk a little bit about the context of this from a management standpoint. How do we engage with folks about these topics? And so I'll start with the world before 2016. And so here was the world before 2016. So these are some of my old slides that I used to use, and so I'll run through them really quickly. So up here on the upper right, that's Hurricane Katrina. Some of you guys are coming with us to New Orleans in a few months, and so we'll talk more about that if you're in the class, and others of you have come with me before. And so this was whether Hurricane Katrina was a direct consequence of climate change. That's not the point. It most certainly was made more problematic because of climate change, but the more important reason is Hurricane Katrina, I would suggest to you, maybe just like Paradise and some of our recent wildfires, it's showing us what will be coming more what's in our future. So whether this exact particular scenario was directly caused by climate change, this is what it's going to look like. And so the displaced peoples, the death, all that kind of stuff is there. This over here on the lower right, this is Vice President Al Gore when he was starting his Inconvenient Truth talk. So we used to see his talks when he was developing them, and so this is from the early 2000s, before he did the movie or anything like that. And he was trying to do an educational tour, and obviously that became a huge political thing, right? Where do you believe in this or don't believe in this, unfortunately. But basically that was a big PowerPoint, essentially, is what he'd do, drive around the country and show this PowerPoint to different groups. This area here on the right, this is from one of my research sites in Turkey, in the middle, I should say. This is a little falafel shop near the Iranian border. And we're having lunch, and my back was to this, so we're looking at a television, which is up in the corner. So my back is to the television, we're eating food, and it's Turks, so everybody's like, you know, they're very loud, and they're talking like Turks, and there's a lot of spit and a lot of yelling. And then all of a sudden, they all got quiet, and they never get quiet. I was like, what? And everybody in the shop turns and looks at the television. And so again, my back was to it, so I turned and I looked like, what's going on? And there's a newscaster there reading something. So I said, oh my God, what happens? There's some terrorist thing or whatever. And my friend's like, oh, hold on a second. And so they're listening, the guy's talking obviously in Turkish. And then after, a minute or two, then he finishes and goes to something else and people get back to eating. I said, what was it? And they said, oh, it's a new prediction as far as what the most recent data from climate change and rainfall was going to be, the predicted precipitation for that year and the coming years for these guys that are mostly subsistence farmers. So they didn't shut up for the soccer report, or football, whatever the hell they call it, right? They didn't shut up for that. They didn't shut up when the president was speaking, but when the climate change revelation came on, everybody got quiet because they all wanted to hear what that was. So this notion of that there's all this disagreement, that's very much so an American phenomenon. Little teeny bit an Australian phenomenon, but primarily it's an American phenomenon. Most of the world does not see climate change the way you and I do. And there's various efforts over here on the right. This is one called Climate Connections, where people were trying to have different conversations in the early 2000s about climate change. So to try to get past these people that can't talk to each other, let's talk about something we can. And then on the upper left over here, this was our then Governor Schwarzenegger, who was a Republican, right? Who has done a lot to try to help early on especially, help our state deal with climate change. This is the then UN Secretary General, and this was the head of a company that my father-in-law worked for that were making smart energy solution things. And so the fact that these guys were meeting to talk about technology that can help reduce our energy consumption with the Silicon Valley dude, with the governor, and the head of the UN, that's an awesome thing, right? So we weren't all super spread apart, and it wasn't like we all hated each other back then. There was obviously clearly disagreement, but we could get together. It is possible to get together. And so now we're 2016 on. So things have changed quite a lot in terms of the management realm, in terms of what we can do with policies and the like. So obviously, our current president is a big fan of fossil fuels, and indeed some of the dirtiest fossil fuels, some of the fossil fuels that emit the worst, the most dense concentrations of greenhouse gases and the like. And famously, one of his most famous tweets, especially when he was running for president, was that the whole concept of global warming was a fraud, right? Perpetuated by some foreign governments to trick you and make you feel stupid and take your money. Clearly delusional, to say the least. That's the situation that we unfortunately have at the moment. So to be clear, just want to run through a couple examples of what's going on. So these are all tweets. I wish we could have policy papers, but we have tweets, unfortunately, to talk about. So this notion of global cooling is ridiculous. That's an outright fallacy, which you might call a lie. So that is not true. And what we tend to see with folks that make these types of arguments is very hasty generalizations and just reality is not correct. The numbers, the values, the terms are not correct. We see other things that people will try to pull out specific cases that are, again, factually incorrect. And then we see a lot of false equivalency, right? So we heard that in the quote earlier where the president in the most recent report said, well, it's not true, but if it were true, we can't do anything until these other guys do some stuff, right? That is not how we've behaved in the past. That's not how we dealt with all these other problems like ozone depletion and human rights, and not that we solved human rights, but you guys know what I'm saying. And so this poison has gotten really crazy, and we're seeing that in a lot of ways. So some people now are saying that these conversations that you guys might want to engage with in terms of different managers or family members, sometimes that poison is a little crazy. So here's some concerning data. So this is polling data, and this is looking at people's party affiliation, et cetera. And on the x-axis is the most important thing here. This is on the left are people that have not graduated high school, and then people with some college, then people that have a college degree, and then postgraduate. Now, to be sure, this postgraduate is mostly master's degrees, and it's mostly probably business and finance type of stuff. But what we see is the biggest difference here is not in the uneducated, as the rhetoric would maybe tell you. The biggest difference in terms of people in one particular demographic bracket think that climate change is something real that we need to deal with or not is in the most educated bracket, right? And so that's of concern. So just simply, what this is saying is just simply giving more facts, that's not necessarily going to change them. Maybe, but it isn't a case of these guys are ignorant, let's just educate them necessarily. Yeah, we should probably skip that. Okay, and so one of the things that has come up in the last couple of years is this notion of active denial, and we now have evidence of groups such as Exxon actively lying to you. And without going into this, they were telling people that climate change didn't exist when they were actually planning in their own internal documents for their coastal facilities to deal with sea level rise, driven specifically by climate change-induced sea level rise and other things. There's been a lot of worry about data, and so this most recent climate change report did come out, to the credit of the president and the government. It did come out, but all our previous reports have wonderful slides, have wonderful multimedia, have wonderful tools to help foster a conversation. That wasn't this. This was just a website, and it was put up right between Thanksgiving and the weekend. And so early on last year and the year before, there was huge worry that data would disappear. So a whole bunch of hacking groups got together and actually started archiving data off US servers. Now, the data, by and large, has not disappeared, but the links to the data have disappeared. So people have not, there's not a lot of evidence people have deleted data or anything like that, which would be illegal, but they've made it many departments and agencies have made it much harder to find climate change related data. And so this data preservation tool was a useful thing. It's easier to destroy than build. President Trump most famously, in terms of all this, well, one, pull this out of the Paris Accords, but President Obama didn't do a huge amount for climate change, despite what some of the rhetoric has become. So he did some things. Those limited things he did were mostly driven around based around executive orders, and President Trump has deleted those, including things that say, like, after Katrina, after our wildfires we just experienced, there used to be an executive order saying that we have to build more resilient, right? So when we do rebuild, we try to make those systems better, able to deal with climate change or sea level rise or whatever. Those have all been deleted, so you don't need to do that now. You can essentially put the same exact system, be it a sewage system, be it a power system, the exact same thing, and that is just beyond silly. Okay. Yeah, and then as I mentioned, he pulled us out of the climate change accord. Okay, so what does our data show? So let's look at our data for a real quick second before we finish up here. And so this is when the hurricane was coming on into Florida. So this is when that first happened, when those were happening last year. Last year's data showed that when we asked, when your predecessors did the poll last year, and they said, hey, so did climate change play a role in the hurricanes from that year? 70% of the respondents said they did, or at least they were likely to have had some kind of impact. With our current fires, where the president would like us to rake America great again, we see a very similar number, right? So when you guys ask people, hey, so the Thomas Fire, this is your data from whatever, 2 months or so ago, very similar to that data about, hey, so do we think that, again, it's not saying 100% cause or whatever, but was there did climate change make things worse or contribute to it? Very similar. So by and large, most folks do understand that there is this link, that there is this tie to some of these disasters, et cetera. Mr. Feeney.
Doesn't this reflect not so true, because there's only California.
We'll look at that in 1 second. Yes, good question. So, okay, we'll skip this. So to get to Mr. Feeney's question, so what about the rest of the U.S.? So this is spatially disaggregated data. So this is our data. In this case, this data was done in 2016. So I've put our 2016 ESRM data up there for comparison. And so is global warming caused by people? Across the U.S., 60, sorry, ignore that for a second. Just look at the map first here, right? So this is all of the voting districts across the U.S. And to be sure, as Mr. Feeney said, there is structure here. There is difference, right? We don't ask the question, will global warming harm you personally? But as with all these questions, there's some variance here. But if we zoom into California, where we have our comparative, our site is comparative. So I extracted the Santa Barbara to LA region from this Yale survey, and then our question. And very similar results. So to be sure, if we jump to this guy, right? So yes, so Mr. Feeney's like, so California is different? Yes, but the long-term trends that we're seeing of this going up and up and up is going on everywhere. So it might be a 10% more or so in California compared to wherever, Wyoming or something, but just about everywhere, the vast majority of people believe that this is going on and that this is a problem. So it's not the case that California thinks one thing and other folks elsewhere. The news stories would have you believe that. The news stories have you believe that these guys hate it, these guys love it. No, just about everybody has a brain in their head. And so to be sure that we still have disagreements, and the powerful folks, the elected forces, that's a different story. But as far as Joe Blow citizen, there really is, the preponderance of people do agree that this is a problem we should deal with, and that it's caused by people. And then just to finish up, so this is from last week, right? And this is probably going to be repeated again, or hopefully it might not, but could well be repeated again this weekend. So this is the so-called Yellow Jackets, or the Yellow Vest protests in France. And this is sparked by the French president increasing gasoline tax, specifically to deal with climate change. And so the protesters will say that this is much more, it's beyond just that. It's about economic inequality and poor folks, rural folks not having opportunity, et cetera. And so that's true, but it was absolutely sparked by the gasoline tax. So increasing to about $6 per gallon for their gasoline. And so this is on the Champs-Élysées. This is in downtown Paris. And these are folks that are rioting and breaking up their national monuments. And these are the police shooting tear gas, breaking up folks. There is no leader for this protest. It's a leaderless movement, but it's basically everybody's just totally fed up, right? And so just yesterday, the French president announced that he was rescinding all of this. We're not going to have any new carbon tax, no new gasoline tax, but there's nobody to negotiate with, right? So this notion of social dislocation and people being angry, this is another consequence of not dealing with climate change, right? In the coastal zone and beyond. So there's certain folks like the folks in power that I don't think it's probably profitable to try to engage them. Some people think two possible things. The climate change doesn't matter to me, that I'll be safe, one, and two, that they feel unable to do anything. And both of those are not true. We can take action. You guys can take action, just like all these management things we're talking about. And one of the first things to do is to talk about it and have serious conversations. So Christmas is coming up. You guys are going to have some great turkey and whatever the heck with your crazy uncle, and you can talk to him about this. But this is a story I always like to tell, and we'll finish with this, which is, so these are a couple of my neighbors. We tend to have a lot of parties in our neighborhood. And so this was a toga party from a few years ago. And these are two friends of mine. One of them, unfortunately, has since passed away. But they're good friends of mine, and they used to tell me things like, this climate change thing isn't real, right? You professor dude, like it's all a trick, right? I'd be like, no, dude, it's not a trick. Yeah, right. And so whenever we do a party or something, the joke would always be making fun of the professor dude. Hey, Jacques Cousteau, what's happening to fish? You know, that kind of stuff. And so the gentleman on the right was a bachelor and had a big honking couple suburban things, giant things, driving around, always like dig, 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 dig. And so I have a Prius, right? Because I'm a nerdy professor dude, right? And so like, hey man, do you ever like get that roller skate on the freeway? Does it ever go fast? You know, so constantly that kind of stuff. So one summer, one summertime, I'm driving up the street. He's down below me on the street, and I'm driving past him, and he goes, hey. And so he signals me over, and I walk over to him, and I go, yeah, hey Tom, what's up? And he goes, so I roll down the window, and he puts his hands on the window, and he starts looking at my car, and he goes, so how many miles per gallon do you get in here? And I was like, oh yeah, you want to know how many miles per gallon? He's like, and he was totally serious. He's like, no, how many miles per gallon do you get? And I went, what? You really serious? And he goes, yeah. And I said, well, when I was up in the Bay Area where it was flatter, I used to get 54 miles per gallon, but now pretty much I get around 47, 48 miles per gallon. Somebody because I have to go up and down the grade and stuff. And then I thought I was ready for some sarcastic, snarky, da-da-da, and he says, so I'm thinking about getting rid of my SUV. I'm thinking about getting a hybrid. And I went, really? And he said, yeah. And so what I wanted to say was, expletive deleted, yeah, right, you bastard. And so I bit my tongue. And I said, well, would you like to test drive my Prius? Like, oh, would you let me do that? I'm like, totally, dude. You want to drive it? Yeah, I want to drive it. Right? I'm like, okay, you can drive it. You test it, whatever. And so we never know when these opportunities are going to present themselves, right? The goal with making any of these management things we've talked about across the semester better is not, idiot, of course I was right. That's not the goal. The goal is to make the management situation better, right? It's not to gloat. It's not to make fun of somebody. It's not to make them feel stupid. When folks do come around to actually seeing it, it might take them losing their house in the Woolsey fire. It might take them, some other horrible circumstances occurring to them. But there will be a time when they will be open to new policies and new management decisions. And so your responsibility, your guys' responsibility is when that happens to, yup, great idea. Well, let's try that, right? And if you are triumphant, yeah, idiot, I told you that 20 years ago, where the hell were you then? They're gonna go the other way, right? That's gonna shove them away. So as hard as it is to bite our tongues at times, you need to bite your tongue, right? You can go and yell when you get back at home, or yell in the bathroom, or like, oh my God, that guy, I can't believe it, right? But don't do it to their faces, right? Let's be respectful. Let's appreciate when folks do see the light and they do see reality. Let's make sure that they keep coming, and we have some responsible adult conversations with those folks. And so one example, this was last night. So this was in Agoura Hills with one of our public information sessions about the Woolsey fire. And this was at the start, so there was a lot more people here later, but I just took his picture and was walking in. All these people were there. Many of those questions were about, what are we doing with the fire? How are we going to prevent another fire from being as bad as this? What do you recommend, right? So in times like this, even though I don't know for a fact, but at least some of these folks, I suspect, were a little bit skeptical about climate change before this, maybe, right? But you can, not that we want to abuse people when they're down or something, but again, we have to be ready when these opportunities present themselves, whether it's some dude putting his head in at the top of your street, or whether it's people coming together. And so it's for you guys, it's for my son. That's my son when he's little at Yosemite. And it's for all of us. So we're trying to do all of these management things and make them better and make better, more responsible decisions. So, okay, so take a quick 10-minute break, and then we'll come back and we'll talk about our seafood service.